Hi, I'm Bob Tabor with LearnVisualStudio.net. In this video, we're going to learn more about working with collections of data. Now, in the previous video, I demonstrated how you can add references to objects into a special type called a collection that will then manage all of those references. So it'll keep track of them all, and we can then iterate through them or access a single one. Better than arrays because we can add and remove, gives us new functionality like being able to not just index into to find a particular item, but also in some cases like the dictionary, able to use a key in order to get at the value. All right, so all those good things we learned about in the previous video. But what else can you do with collections of data besides just index in or loop through them? Well, suppose that you needed to filter a list of, say, 1,000 items in a collection and only work with a subset that meet a specific criteria. So this is made possible through a relatively new innovation that was added back in C# 3.0 called link to objects. And so in this lesson, what I want to do is explain the rationale behind link and then provide a few examples to get you started with working with link in your applications, filtering large collections of data. So I have open now Microsoft SQL Server, which is a database product from Microsoft. If you're familiar with relational databases and querying the data in a table using structured query language, or SQL, some people call it just SQL, then you'll undoubtedly be familiar with selecting data from a database table like this. And I'm going to hit the execute button, and you can see this will bring back all of the rows of data in my customers table. So I'm selecting all columns from the customers table. Now I could filter this down and only select, for example, several specific columns. So that's one way that I can filter the data. Let me go ahead and try a different way here. Let me find all of those customers that have a credit limit in excess of $1,900, or $19,000 rather. All right, so as you can see here in the results near the bottom right-hand corner, that filters this particular table's data from 1,000 rows down to 97 that meet that criteria. I can further limit the data that's brought back by adding additional where clauses. So, and customer since is greater than January 1st of 2009 at midnight is implied. Okay, that filters it down to 26 rows. And then I can even filter it further. Since I'm going to be a salesperson in Illinois, I want to find those that have a high credit limit and are relatively new customers in Illinois so I can pay them a visit. And that limits it to just 2 results. Okay, so when you think about it, working with a set of rows that are stored in a table like we just did here for a moment is similar to working with a sequence or a set of objects that are stored in a collection. They're similar concepts. So some smart people at Microsoft asked, well, why can't we use a syntax that's similar to this very simple SQL syntax in order to query objects in our collections? And that's exactly what they came up with in the form of link. It allows developers to use a syntax that they're probably already familiar with in order to run queries against collections of objects. So let me set up a project for us to look at and learn more about link. And to set up this project, I have a before snapshot of a project. So I'm looking at the ch9 CS22 folder, the before folder. I'm going to copy this, and if you want to follow along, you should do the same thing. I'm going to paste it here in my projects directory. I'm going to open it up and double click the solution file. Okay, so you can see what we have is a collection initializer of a number of new car objects, and I've already set up all of their properties, initializing them to some values. Notice a few things about our car class that we're using. Has a make, model, that are strings, a year, which is integer, a sticker price, which is double, and then a color, and I've created a car color enumeration, okay? And then I'm simply just looping through to list all of the items within this short collection now. Again, I just took a few moments to create a few items. You could make this list much longer and further practice with Link. So let's do something very simple to start off. I'm going to remove this little line that says we'll add code here, and let's go ahead and add some code. So what I want to do is write a link statement that will retrieve all of the BMWs from this list, and that looks like I have 3 here. So I'm going to use that var keyword for now. BMWs equals from car in my cars, where car.make equals BMW select car. Now I'm going to replace my cars with BMWs. And now I'm going to run the application. And you can see now we have a subset of our large list by performing a link operation on that large collection to filter it to just those that meet our criteria. So if we wanted to add an additional criteria, maybe we could find only those that are both BMW and the year is 2010. And you can see we have one that matches that criteria. All right, so I can use any identifier here. I just use the word car because it's kind of similar to what you see down here below, where it's one instance in a larger collection. The same thing is true here. So one instance in a larger collection. Evaluate each instance against its year and its make in this particular case, and then select that instance, adding it to our new collection. Okay, so that's roughly what the syntax is accomplishing here. All right, now as I demonstrated when we were looking at the SQL syntax, I was able to not only filter by the number of rows, but I was also able to filter the columns as well, and you can do that through a process that's called projection. So in order to do that, we'll create a new data type. And the reason why you might want to do that is because while an object may have dozens of potential properties that have been defined, you may want to select only a subset of those and work with just a few in order to conserve memory or just to generally make it less unwieldy. Okay, so let's create another link statement here. Var new cars equals from cars in, from car in my cars, where car.year is greater than 2009, and I don't have to use a where clause. I just chose to do that. So now instead of selecting just car, I'm going to project out a new set of columns now, or rather a set of properties. Now when I do that, the type that's returned is no longer a car. It started as a car, but now it has fewer properties than a car. It's a new type. It's a type that's created on the fly. It doesn't have a name. It's anonymous. It's a new anonymous data type. Okay? Don't worry about anonymous data types too much. However, I will say this. That's why we use the var keyword. We're going to let the C# compiler figure out what the data type should be. We're not giving it a name. We'll let the C# compiler figure out what its name should be. Okay? And we'll see that in just a moment, how that's manifested. So select new car.make, car.model, and car.year. And then we'll just change this from BMWs to new cars. Now let's run the application. You can see we're looking for all of those cars that are greater, where the year is greater than 2009. So we just have 2 results. What's more interesting about this example, however, is if we were to place a breakpoint, let's say right there, and then run this application, let's look at the data type for car. If I were to hover my mouse cursor over, first of it's pretty easy. It looks pretty neat. It gives us the car object and the current one and all of its properties. You can see it only has 3 properties: make, model, and year. All the rest of them have been ignored. Look over here in their locals window. If you look at the value, and as I hover my mouse cursor over it, you can see that we are working with new cars, which is of type system.link.enumerable where select list iterator of type understand link.car, and then kind of buried in there is that anonymous type. We have created a new type without a name, so it's anonymous, that has both a string, and an integer as part of its definition. In other words, the make, the model, and the year. Okay, so don't worry too much about that, other than to just understand that is really the true value of the var, is to resolve at runtime the shape of a new class that would be difficult for us to ascertain ahead of time. All right, it's created dynamically. All right, so additionally, we can do things like sorting from the newest car to the oldest car. So let's go again here. We'll call this ordered cars equals from car in my cars. Order by car.year, select car. Now I intentionally left something off so we can see how this works. So I'm going to call this ordered cars, and now let's get rid of that and let's run the application. And you can see we are not going from oldest to newest, or I'm sorry, from newest to oldest. We're going from oldest to newest. So how do we change this sort order? Well, we change it using descending keyword. So order by car.year descending. So by using that, we'll go from the newest to the oldest in our list. Okay. Now, in addition to this SQL-like syntax, you can accomplish some of the same things using another version of this called the method syntax. So I'm going to create a version of this query using a more method-based syntax, something that might be more familiar to you up to this point. Let's go underscore BMWs, and let's run the application. And then I'll come back and talk about the syntax. Okay, we get the same results we got before. So we're able to use, again, a methodized version where we're calling a where clause, and then we're chaining together another where clause, and we can continue to chain together different clauses to sort, to filter, to order, things of that nature, until we are able to find and filter just the data that we're looking for. So the syntax is: given a car, return cars that meet this criteria. Given the fact that we're working with cars, just like here, like this from car and cars, find those cars where the make is BMW. Okay, so let's go on and do one more and look at ordered cars equals my cars dot order by descending, and I'm going to use a different identifier. You'll see often just a single letter, like the letter P or T or O or something like that. The same thing is true, though. It doesn't matter what you call it. It's just a convention that they've come up with. So we'll see that often in examples. And so then let's go ordered cars, and we get the same results where it's ordered from the newest to the oldest. Okay. Now, one other thing that you can do that's kind of neat, let's move down here, is that there are other methods that are available to your collections as well. It's a slightly different type of functionality that's available, but I'm just going to go ahead and lump it in with what we're working on here. You can get a sum. So given a car, give me a sum of all the cars' sticker price, and then console.writeLine. Inside here we're going to go total inventory value, and then we're going to use our string formatting syntax to get a currency value, and we'll give it the sum. Alright, so let's run our application now. And you can see our total inventory value from all of our cars is $250,000. Okay, so I realize that some of this syntax might look foreign. I hope I took the time to explain it, and at least you can understand the basics of what we're trying to get at, even if you can't just off the top of your head now redo this whole lesson and you haven't just memorized it, okay? Hopefully it makes sense, the thought process and what you can accomplish by using link queries within C#. Again, kind of a new concept, but you'll see it often as you look at examples on MSDN and over the internet. All right, so we're just about ready to wrap up with the next lesson. We'll see you then. Thank you.